Welcome to Educator.com. Today we're going to work on another method of solving quadratic equations. Previously we used graphing and completing the square. Both of those methods have some limitations, and this method is actually very useful. So the quadratic formula works as follows. First, to solve a quadratic equation in standard form. So standard form means that it's in the form ax squared plus bx plus c equals 0, where a does not equal 0. Because if a were to equal 0, this would drop out, the x squared, and it wouldn't be a quadratic equation. Okay, so remember, we're talking about standard form, and in order to use this formula, you need to first put the equation in standard form. So this gives the quadratic formula, and you'll become very familiar with this formula. Let's apply this to an example. That's the best way to explain it and to understand it. 2x squared plus x equals 2. First, this is not in standard form, so I need to put it in standard form by subtracting 2 from both sides. Now that it's in standard form, the first thing that I'm going to do is determine what my a, b, and c are, because I'm going to need those for the formula. Here, a equals 2. B equals 1, and C equals -2. So I'm going to substitute my values for A, B, and C into this formula to get x equals -b, so that's -1, plus or minus the square root of 1 squared minus 4 times A, which is 2, times C, which is -2, and all of that is divided by 2 times A, which is 2. Now just to do some simplifying, 1 squared is 1, and this is minus 4 times 2, which is 8, times -2, so that is -16, divided by 4. Can be further simplified into x equals plus or minus the square root of 1 plus 16 all over 4. Finally, we get x equals -1 plus or minus. So then x equals -1 plus or minus the square root of 17 over 4. Okay, and this would give my two solutions for this quadratic formula, although recall that you may have situations with the quadratic equation where you have a double root, so you only have one unique solution, or there may be no solutions. So no matter what method you use, of course, you could come up with either of those three situations. The discriminant, d, is simply the expression that is under the square root in the quadratic formula. The discriminant is very important because it tells you the number of solutions and the type of solutions that you're going to get. As I mentioned, there are three possibilities with a quadratic equation in terms of solutions. If the discriminant is positive, so if d is greater than 0, you will have two solutions, and both are real numbers. Both are real solutions. If the discriminant equals 0, you get one real solution. Actually, technically, you get two solutions, but they are the same. This is the situation with the double root, so only one unique solution. If the discriminant is negative, if the discriminant is less than 0, there are no real solutions. So there are solutions, but they are not real numbers. They are not real solutions. And let's think about why this is. Recall that the quadratic formula is as follows. If the discriminant is positive, then what you're going to get are, you're going to get the square root and the positive and the negative of that, plus or minus whatever you come up with here. So if D ended up being 4, for example, then I would get plus 2 and negative 2, and I'd work that out with the rest of the formula, and I'd end up with 2 values for x. So I get 2 real solutions. Now, let's say that D is 0. So if D equals 0, I'm going to end up getting plus or minus 0. Well, there's only one square root that you're going to end up with, it's 0, and whether you have a plus or a minus in front of it doesn't make any difference. So since you're only going to have a single value here instead of 2 values like you did right here, you end up with just one unique solution. If the discriminant is negative, then you're being asked to find some kind of, let's say, negative 4. A negative number, you're asked to find the square root. But this does not equal a real number. The square root of a negative number does not equal a real number, so there are no real solutions. So this explains the background, but the important thing to know is what it means, the type and number of solutions given a certain type of discriminant. Okay, now applying the quadratic formula to some quadratic equations. First thing, we need to make sure it's in standard form. And this is in standard form, so I can just go from there. Recalling that the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Here, a equals 2, b equals negative 3, and c equals negative 7. So b is negative 3, so negative times the negative 3, plus or minus the square root of b squared, this is negative 3 squared, minus 4 times 2 times negative 7, 4ac, all of that divided by 2 times 2. Do some simplification. A negative and a negative gives me positive. Negative 3 squared is 9. Minus 4 times 2 is 8, times negative 7 is negative 56. Be really careful with the signs, because if those are mixed up, the answer is going to be incorrect. Continuing to simplify, this is a negative and a negative, so I end up with positive 56. 9 plus 56 is 65. Divided by 4. Okay, and I can't go any further with this, so my solutions for x are that x equals 3 plus or minus the square root of 65 divided by 4. And this was simply a matter of checking to see that it's in standard form, finding a, b, and c, and recalling the quadratic formula. And as you can see, this is much easier for this situation than, say, completing the square or trying to graph this. It would be very difficult to get an answer. So let's look at the next example. This example is not in standard form. In order to put it in standard form, I need to add 8 to both sides. So the first step, put in standard form. The second step is use the quadratic formula. So by adding 8 to both sides, I'm going to end up, and since I want this all on the left, I'm going to go ahead and subtract 6x from both sides. So I'm going to end up with negative 4x squared minus 6x plus 8 equals 0. So subtract 6x from both sides, add 8 to both sides, end up with a quadratic equation in standard form. I always stop and jot down what a, b, and c are, especially when I have negative signs involved. A is negative 4, b is negative 6, and c is 8. Second thing to jot down, if you don't really have this down, is quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Substituting in these values, I get x equals negative times, and then that's negative 6, b is negative 6, plus or minus negative 6 squared minus 4 times a, which is negative 4, times c, which is 8, all of that divided by 2 times negative 4. Doing the simplification, x equals negative and a negative gives me a positive 6, plus or minus the square root of negative 6 squared is 36, minus 4 times negative 4 is negative 16, times 8 is 100, so then I get negative 128. So negative 16 times 8 gives me negative 128 divided by negative 8. Okay, a little bit more work to do. This becomes a positive, so a negative and a negative, that becomes plus 128. Finishing out, this gives me 6 plus or minus the square root of 164 divided by negative 8. Now, this radical actually can be simplified further, but we haven't quite gotten to that yet in this course. However, there are techniques to further simplify this. For this question, though, we're just going to go ahead and leave the solution as it is right here and then learn those techniques later on. The important point is that you remember to put this in standard form, find the a, b, and c, and then carefully apply the quadratic formula, keeping track of all the signs so that you don't end up with an error. Okay, in this example, we have another quadratic equation, but it is not in standard form. So I'm going to rewrite this in standard form. Subtracting 60x from both sides and adding 150 to both sides. Whenever I see large numbers like this, I always look for a greatest common factor. And this does have a greatest common factor. The greatest common factor equals 6. Divide both sides by the GCF, which is 6. Doing that gives me x squared minus 10x plus 25, which equals 0. Okay. Now, there's a couple ways to handle this. This is a perfect square, so you could actually factor this out and then use the zero product property to find the solution or solutions. You can also use the quadratic formula. So for more review on that formula, I'm going to go ahead and use that method. But always remember, there's multiple methods, and you should pick the easiest one for the situation that you're in. Both of these are actually pretty easy. So here, a equals 1, b equals negative 10, and c equals 25. Quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, substituting that in, x equals negative b, so negative negative 10, square root of negative 10 squared, minus 4 times a, which is 1, times c, which is 25, all over 2 times a, which is 1. So x equals negative times a negative is a positive. Negative 10 squared gives me 100. 4 times 1 is 4, times 25 is 100, divided by 2. Well, what happens here is I end up with 0 here. It should be plus or minus right there. 10 plus or minus. So what I end up with is 10 plus or minus the square root of 0 divided by 2, which gives me 10 plus or minus 0 divided by 2, or x equals 5. Now, what you see here is that you actually only have one solution. And the reason is because the discriminant equals 0. So in the previous example, we had two solutions, and the discriminant ended up being positive. Here, the discriminant was 0, so plus or minus 0 is plus or minus the same number instead of two different numbers, so you just end up with one solution. Okay, this time we're just asked to determine the number of real roots for this quadratic equation. We're not even asked to solve it, just figure out the number of real roots or solutions. Remember, roots and solutions are interchangeable terms when we talk about quadratic equations. So, as I just mentioned in the last question, in the last example, if you know the discriminant, you know the number of solutions and the type of solutions. Recall that the discriminant is the part of the quadratic formula that lies under the square root sign. So the discriminant equals b squared minus 4ac. For this quadratic equation, a equals 3, b equals 4, and c equals 7. So this is a simple matter of substitution. b is 4, so b squared minus 4 times a times c. So d equals 16 minus 4 times 3 is 12. 12 times 7 is 84. So d equals 16 minus 84, that is negative 68. Since the discriminant is negative, so the discriminant is less than 0, there are no real solutions. As I just mentioned, if the discriminant was equal to 0, there would have been one unique solution. If the discriminant is positive, you would have had two real solutions. So there are no real solutions to this quadratic equation. And that finishes up this lesson for Educator.com, and I will see you soon.